Alright, for section 512, which we're starting on Friday and we'll do questions and wrap up on Monday, we are solving equations after factoring them out. So I want to run through the examples and then do a few problems from the assignment, which is 3 through 54 multiples of 3. Now, your goal of this section is you're looking at this x plus 2x minus 5 right here. And you need to set each of those equal to 0. And find out what could x be. It makes that set of parentheses 0. Well, in this case, x could be 5, or x could be negative 2. If you enter that in to this problem, either a 5 or a negative 2 will make this equal to 0. Now, the way you show that is draw little brackets, make negative 2 and 5, and you are done. Actually, those are called braces there. For example 2, you have 1, 2, 3 different things that could equal 0. 0 times anything is 0, which is why this is true. So I'm going to set 5n equal to 0. So obviously n could be 0. Then I'm going to set n minus 3 equal to 0. So n could be 3. And I'm going to set n minus 4 equal to 0. So n could be 4. So all of those are solutions that would make this statement true. All right, moving into example number 3. Now here you don't have anything equal to 0. That's a quick fix though. Turn it into a trinomial on the left side of your equal sign. Now you have 2x squared plus 5x minus 12 equals 0. Now you need to factor this into a trinomial into two binomials. You've got 1 and 12, 2 and 6, and then 3 and 4 is another factor of 12. And I'm trying to get to 5. Looks like 3 and 8 will do the trick for us. So your binomials will be 2x and x. The 2 has to multiply by the 4. And the 1x needs to multiply by a 3 to make this happen for us. So positive 8 minus 3. Alright, now 2x minus 3 equal to 0. When I solve for that, what I get is my constant on my variable side turns into my numerator. Don't forget to make the opposite sign. Then the coefficient of x is going to turn into my denominator. So 3 over 2 is one solution that will make this 0. And then x plus 4 equals 0. Obviously, x would be negative 4. So when you write that solution, you're going to have 3 over 2, negative 4. And the order of those will not make any difference. Alright, and example 4 just steps up the level of difficulty when it comes to factoring just a little bit. You have an order and a common factor issue. So I can take 2y out of every term, and that becomes 9y squared plus 4 plus 12y equals 0. This isn't in the right order to factor. These need to be switched around. So what I will be factoring is a 3 and a 2, and that actually becomes a perfect square. All right, good. In this case, I don't have to do two separate parentheses since they're the same, so I have 2y can be set to 0. I also have 3y plus 2 can be set to 0. When you solve 3y plus 2, what you end up with is 3y equals negative 2. Divide both sides by 3. So one of my solutions for y will be negative 2/3. The other one will be y equals 0. So 0 and negative 2/3 are two solutions on that example. All right, now let's look at a couple of the actual problems from 3 through 54, multiples of 3. The first one will be problem 18. Now you've got 9k squared equals 4k. You need to have a 0 side. So let's keep my leading coefficient positive, so we'll move everything to the left. 9k squared minus 4k equals 0. You have a k in common in both terms. Let's factor that out. That leaves me with 9k minus 4 in parentheses. And now I have two things to set to 0. Here's the first one, and here's the second one. So I have k equals 0 for the first one, and I have 9k minus 4 equals 0 for my second solution. To solve this, I add 4 to both sides, and then I will divide by 9. So k can be 4/9 or 0 for problem number 18. Next, let's look at number 36. You have 6c squared minus 72 equals 11c. So I'm going to make my 0 side by putting my 11c in the middle. We're used to that format, and I'm doing that by subtracting 11c from both sides. I don't have a common factor, so let's factor that into trinomials. 6 has 3 factor pairs. 2 factor pairs, excuse me. And 72 has a couple more. You have 2 and 36, 3 and I guess that would be 24. You have 4 and 18, 6 and 12, and 8 and 9. Now I need to find out some combination that gets me to 11. Let's see, 24 and 9 won't work. 18 and 12 won't work. This is where you might be thinking it over for a little while. 27 and 16 will do the trick. Let's go ahead and get that trinomial factored. I'm getting to 6c squared by doing 2c and 3c. I know that my 2 needs to multiply by an 8. My 3 needs to multiply by a 9. And I need a larger negative number. Okay, so now that that's factored, I'm going to set 2c minus 9 to 0, and I'm going to set 3c plus 8 also to 0. So that becomes 9 over 2, and this becomes negative 8 over 3. And you'll get pretty used to how that works as we finish. So put them in answer form, and you are done with 36. All right, next, let's look at 45. Now here, I don't have it equal to 0. It's ready to solve if this was 0, but I definitely cannot do this equals 6 and x plus 3 equals 6. That does not work. Big no. What I have to do is actually FOIL this out. I have to do x squared plus 3x minus 2x minus 6. Let's do that. X squared plus 3x minus 2x minus 6 equals 6. And I'm going to make my 0 side by taking 6 away from both sides and combining like terms. So now I'm at x squared plus x minus 12 equals 0. And now we're back on track to getting my solutions to x. X squared is x times x. I want a positive 4 and a negative 3 to get me a positive 1x in the middle. Therefore, my two values of x that would make this 0 are a positive 3 and a negative 4. Now, on page 233, I'm going to do a sample 2 with you. Now, what this is doing is it's giving you that your solutions of x are 2/3 and negative 4. So it's giving you an end result, and what you have to do is come up with an equation that this is the answer to. And here's how that works out. If x equals 2 over 3, what I want to do is create a binomial to where 2/3 makes this 0. The easiest way I can think of really to show you that is if I multiply both sides by 3, then my 3 gets cleared on the right side. And then subtract 2 from that. And what I have is 3x minus 2 equals 0. That's what I'm looking for. All right? So 3x minus 2 will give me 2/3 as a solution. Now, if x is negative 4, then I can add 4 to both sides, and I get x plus 4 equals 0. So x plus 4 can also be 0. And here is the binomials that works with. Now, when you FOIL that out, you get 3x squared plus 12x minus 2x minus 8 equals 0. Simplify everything, and you get 3x squared plus 10x minus 8 is 0. All right, now the book shows it in a little different fashion there, and you can go through how they've done it. What they did is using each one of these terms, you have x minus 2/3. That's your first one. And then you have x minus negative 4 or x plus 4 equaling 0. Okay, so ignore that mark. At that point, it takes you through a clearing process with this 3 underneath your 2 as your denominator. And you end up at the same place. If you multiply this by 3 and you distribute, it's not going to make it all the way over here to the x plus 4. It's going to be used up right here. So that parenthesis turns into 3x minus 2, x plus 4 equals 0. So it all depends on what looks easiest to you. You've got a couple ways of doing it. In this way, a lot of times this is a mental step. I showed work up here, and we'll look more into that on Monday if that's confusing. But follow the book example, kind of look and see again, rewind and see how I did this, and see if one of those makes sense. You will only have one more of those to do, number 54, after I show you 51. So, well, 51, you got x could be 5 over 2 or negative 2. This is the easy one. If x is negative 2, then x plus 2 is 0, because you add 2 to both sides. Right? So those cancel to 0. So that's one of your binomials that you're working with in your problem. Now you had a 5 over 2 part. Now if you think about where the 5 over 2 comes from, I'm going to multiply by 2 on both sides, and then I'm going to subtract 5. So I get 2x minus 5 equals 0 is what gives me 5 over 2. Add 5 to both sides, divide by 2, and I'm back to where I started. Alright, I'm going to show that the rest of the way. So that is 2x minus 5. So when you FOIL that, you've got a positive 4x, you have a negative 5x. Your first term is going to be 2x squared minus x minus 10 equals 0. Right? If you need to FOIL that out the 4-step way, that's fine. But this would be your equation that you're looking for problem number 51. And I think that's it. You've got through 54 to do. You're going to do 54 the same way as 51 for the most part. And then we'll cover any other questions you might have on Monday. All right? Good luck with it.